now that I'm starting my video. Okay, anyway. So number 6 says factor each expression to find all zeros, and you can see that this is in a quadratic form. So what we need to do is go ahead and treat it as if we're factoring it like a quadratic. So I'm going to multiply 2 and negative 10 and get negative 20. And so I want to find the factors of negative 20 to add up to the middle number, negative 1. And that is a negative 5 and a positive 4. So I'm going to write, now because it's x to the 4th, normally we would just write x minus 5 and x plus 4. But because it's x to the 4th and x squared on the inside, these are both x squared. And if you think about that, if I were to multiply these two out, x squared minus 5 and x squared plus 4, when you distribute, you get x squared. Now we're not done. You get x to the 4th, and then you get 4x squared negative 5x squared, which is negative 1x squared, which is good, but we need that 2 in the front, which is why you can't stop right here. You actually have to divide by the leading coefficient, the number you divided by. Okay, so this is x squared minus 5 halves, and this is x squared plus 2 equals 0, because I want to know what all the zeros are. Now, I'm going to take a second, though, and do this by factor by grouping. So just in case those of you that prefer that method. So if I have 2x to the 4th minus x squared minus 10, you go ahead and do that. You know the factors of negative 20 that add up to negative 1, negative 5, and positive 4. And so then you write 2x to the 4th, the first term, minus 5x squared, like the middle term, plus 4x squared minus 10. And then you group the first two and the last two. Factor out the common factor, which is x squared, and you're left with 2x squared minus 5. Factor out the common factor, which is 2, and you're left with 2x squared minus 5. So 2x squared minus 5 and x squared plus 2 equals 0. And that is the same thing as this right here if you do bottoms up and bring the 2 up to the front. However, since I'm trying to solve for what the zeros are, I don't need to do that. I'm going to say, okay, so when does x squared minus 5 halves equal 0? When x squared equals positive 5 halves. In order to solve for x, I need to take the square root. So I'm going to say x equals plus or minus the square root of 5 over 2. Okay? Which is technically the square root of 5 over the square root of 2, and I don't like square roots in the denominator. I know I didn't do this whenever I worked it out, but I just want to go ahead and show you in case it was multiple choice, it wouldn't have that option. It would have plus or minus the square root of 10 over 2, and that would be your answer. So that's 2 of my answers, but I've got 2 more. I want to solve for when x squared plus 2 equals 0 as well. So x squared plus 2 equals 0. Subtract 2. X squared equals negative 2. X equals plus or minus the square root of negative 2, which is imaginary because of the negative. So then we write plus or minus the square root of 2, I. And there's your other 2 answers. Okay, so that is number 6. And we're going to go to number 10. Okay, so for number 10, it says we're going to divide using synthetic division. Now, in the half box, you have to remember that you put what makes this equal 0. So 4b minus 5 equals 0 when b equals a positive 5/4. You add the 5 and divide by 4. So I'm going to put 5/4 in here. Okay? Okay, so then I'm going to, across the top, make sure they're in order and there's no missing 4, 3, 2, 1, none. Okay. So 12, negative 27, negative 17, 60, and negative 25. Okay, so now I'm going to start doing synthetic division. Bring down the 12. 5/4 times 12. Well, 12 divided by 4 is 3, and 3 times 5 is 15. Okay, negative 27 and 15 is a negative 12. 5/4 times a negative 12 is a negative 3. So it's a positive 3 right there. It's a negative 3, which makes us negative 20. 5/4 times a negative 20. Negative 20 divided by 5 is negative 5, so that's a negative 25. Okay. 60 minus 25 is 35. Did I get everything right? 12, negative 27, negative 17, 16, negative 25. 5 fourths, 12, 15, negative 12. Oh, why did I write negative 3? Oh, I didn't multiply by 15. My bad. I knew something was wrong. Okay, so that is 1232. Good. So then 5 fourths times negative 32. 32 divided by 4 is 8. So 5 times negative 8 is negative 40. That's 20. There we go. And then 5 fourths times 20, we already said was 25. So there you go. Okay. So that has a remainder of 0, which means it is a factor. But if I'm trying to write what the answer is, then I start with the power of 4. So this is a power of 3. So 12b cubed minus 12b squared minus 32b plus 20. And that is my final answer. Okay. No, 13. 13 says expand using Pascal's triangle, so I need 3. So I'm going to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And I need the one with the 3's, so that is the row I need. Okay? So I put 1, 3, 3, 1. Okay. So then I'm going to use, the first term is 2x. So I'm going to go 2x to the third, 2x squared, and 2x. And then the last term is negative 5. So I've got negative 5 to the third, negative 5 squared, and negative 5 to the first, and no negative 5. Okay, so then the idea is to add each term and simplify. Okay, so remember that when you're raising a quantity to a power, if they're being multiplied on the inside, then you distribute the power. So this is 2 cubed, which is 8. This is x cubed. Okay? This is 3 times 2 squared, which is 4, times x squared times a negative 5. Well, that's 12 times negative 5, which is negative 60 x squared. A negative 5 squared is a positive 25. Anything a negative squared is positive, but a negative cubed is negative because it's raised to an odd. So we'll have to think about that in a second. So 3 times 2 times x times 25. That is 6 times 25, which is 150. So 150x. And then negative 5 cubed is negative 125. And that is my answer. Okay. Now let's do 16. Okay, it says using the given roots and synthetic division, find all roots and write the function in factor form. So, okay, they gave me 2i. So I'm going to do 3, negative 11, 8, negative 44, and negative 16. Remember that when you're doing these imaginary numbers, you probably want to give yourself some space. So, first I'm going to bring down the 3. 3 times 2i is 6i. One's imaginary, one's real. I can't combine them, so I just have to write them together. Negative 11 plus 6i. Now I'm going to multiply 2i times negative 11 plus 6i. So I'm going to multiply 2i times a negative 11 plus 6i. So I'm going to distribute and simplify. 2i times negative 11 is negative 22i. 2i times 6i is 12i squared, and I squared makes it just a negative 12. So negative 12 minus 22i. But now we need to add 8 and negative 12 add up to a negative 4, and then negative 22i. So now I'm going to multiply 2i times negative 4 minus 22i. Okay, so I've got a negative 8i, and I've got a negative 44i squared, which makes it a positive 44. So, positive 44 minus 8i, those cancel out, and I'm left with a negative 8i. 2i times negative 8i is a negative 16i squared. I squared makes it positive, so positive 16, 0. Okay, now, you have to remember that if you have an imaginary solution, then that means you also have, if you have the positive one, then you also have the negative one. Okay, sorry, I was just checking the volume. I don't even know if the volume is going to have been working this whole time, so we shall find out. Okay, I'm going to do negative 2i, and then bring down the 3. 3 times negative 2i is negative 6i. Those cancel out, negative 11. Negative 2i times negative 11 is positive 22i. Those cancel out, and I'm left with negative 4. Negative 2i times negative 4 is a positive 8i, and those cancel out, and I'm left with 0. Okay. So now I want to find the rest of the factors, right? So this is order to the power of 4. I factored out 2, so it's the power of 2. 3x squared minus 11x minus 4 equals 0. Now, if it factors, great. If it doesn't factor, then a quadratic formula. Or completing the square. So it's just whatever one makes sense to you. So if I multiply this times 3, 3 times negative 4, I get negative 12. Factors negative 12, add up to negative 11, or negative 12 and positive 1. So x minus 12, x plus 1, divide by 3. So x equals, because this is x minus 4, x equals positive 4 and a negative 1/3. So if I were going to write this out in factor form like it asks, I've got x plus 2i, x minus 2i, and then I've got x minus 4 right here. And then this one right here, bottoms up, 3x plus 1. And that's the factor form. There's the other two zeros. And there's the third 0, other than the first one you got. Okay, now we're going to do number 20. Okay, so the first thing I'm going to do is I'm going to multiply what's inside the roots together. So this is 2 times 1 big cubed root. 9 times 9 is 81. X to the 6 times x to the 3rd is x to the 9th, and then y to the 9th. Okay. Did you lock the door? Okay. Okay. So at this point, I need to take the cubed root of 81 if I can, and actually I can't because 81 is 3 to the 4th, but 27 goes in 81 3 times, and the cubed root of 27 is 3. I've already got a 2 on the outside, so that stays up there, and then this 3 stays inside the cubed root. Now, that's just a 6, okay? And then you have to ask yourself, how many times is 3 going to 9? And it goes into it 3 times, evenly, and again. So my final answer is 6x cubed y cubed times the cubed root of 3. Okay? I could go over 21, but I can go ahead and tell you that it's not going to be on the test, so we're not going to worry about it. Okay. Alright, let's do 27. Okay, the first thing I'm going to do is I'm going to deal with this, and then I'm going to talk about rewriting the whole thing. You have to remember that when you're raising to a negative power, that means technically it goes on the bottom. So what you could do to make your life a little bit easier is distribute this whole thing to the bottom and make that a positive 2. Okay, and now if I distribute my square, then I know, okay, I'm going to go ahead and rewrite everything as is, even though we could go ahead and start moving things, but we're going to go ahead and leave it. Over 6a to the 5th, b to the negative 8th. Okay, 3 squared is 9, and c cubed squared is c to the 6th. So now what I'm going to do is I'm going to rewrite with all positive powers. So, well, I'm going to go ahead and simplify 2 and 6. 2 divided by 6 is 1/3, so I don't need that. And 3 times 9 is 27. Okay, a to the 4th stays on top, but b to the 2nd goes on bottom. A to the 5th stays on bottom because it's got a positive power, but b to the 8th moves to the top because it's negative. C to the 6th stays on bottom, and then all I need to do is simplify. 2 of these b's cancel out with 2 of those, leave me with 6. 4 of those cancel out with 4 of those, leave me with 1. So final answer, b to the 6th over 27a to the 1st, c to the 6th. And there you go. Alright, 40 is pretty easy, it's just converting. If I've got it in log form, the exponential form would be a base log raised to b equals 41 over 25. And there you go. So a to to log base, so you're writing on the screen, log base, the base of the log is base of the exponent, so 14 of 196 equals 2. Okay. Let's look at 2052. So 52 has this right here. Now, what you need to notice, though, since they both have powers of x, you can't just convert to a logarithm. But because 25 and 625 are both powers of 5, then I can write 5 squared in the place of 25 to the 2x plus 2. And then I can write 5, that's to the 4th, to the 4th to the x. And since what we're dealing with is 5 to something equals 5 to something else, the 5's already equal each other. You don't need to worry about that anymore. So you're really just dealing with when does 2 times 2x plus 2 equal 4x. So this is 4x plus 4 equals 4x. If I subtract 4x from both sides, I'm left with 4 equals 0, and that's not true. So there is, in fact, no solution. Okay. Now, 57 on is what we're going to work on now. And for 57, what you notice is that there's 2 logarithms equal each other. Well, just like when I have 5 to this equals 5 to that, 5's already equal each other, so cancel out. Logs already equal each other. So you're really just dealing with when does 2x plus 2 equal x squared minus 6. Now this is a quadratic that you want to solve, so you probably want to move everything to the same side. I'm going to subtract these two to get them on this side, because this is the side of the positive quadratic, and I'd like to keep it that way. X squared minus 2x minus 8 equals 0. Factors of negative 8 that add up to negative 2 are negative 4 and positive 2. So x minus 4 and x plus 2 equals 0. X equals 4 and negative 2. Okay? But remember, you're not done until you've checked your answer. So if I plug in a 4, I've got 2 times 4, which is 8, plus 2, which is 10. If I got 4, that's 4 squared is 16, minus 6, that's 10. Log of 10 equals log of 10, that's correct. Now let's do negative 2. Log base 14 of 2 times negative 2 is negative 4, and negative 4 plus 2 is negative 2. Remember, logs of a negative number do not exist, because they have that horizontal asymptote. They don't exist anywhere over here. So, that's an extraneous solution. Okay. Well, okay, here I've got 2 logarithms separated by addition, which means I need to combine them using multiplication. So log base 4 of x plus 9 times 8 equals 1. So log base 4, 8x plus 72 equals 1. And if you've got a log equal to a number, so this is a log equal to a log, cancel them out. If you've got a log equal to a number, convert to exponential. 4 to the 1 equals 8x plus 72. And then just simplify and solve. So I would minus 72 and get a negative 68 equals 8x. So x equals a negative 68 over 8. That's 34 divided by 2. That's 17 divided by 4. So negative 17 halves. I'm not sure answer, I think. Okay. If I got my simplification correct. Alright, so now this one. Again, I've got a log separated with another log by addition, which means combine their insides. So log base 7 of 9 times 3x squared equals log base 7 of 48. Now we're right here. The same situation. I've got a log equal another log. Cancel them out. So 27x squared equals 48. Okay. We have 27 equals 4x squared, or 27x squared equals 48. I'm going to divide by 27. And I notice that they're both divisible by 3. So if I divide that by 3, I get 16. If I divide this by 3, I get 9. And then if I want to solve for x, then I'm going to take the square root. And when you take the square root, there are 2 answers, plus and minus. X equals plus and minus 4/3. And there you go. let's talk about secant. Remember, as far as your trig functions go, there's sine, there's cosine, there's tangent, and the reciprocal of sine, 1 over sine. Okay, this is being a dork. Is cosecant of theta. The reciprocal of cosine is secant of theta, and the reciprocal of tangent is cotangent of theta. Remember, S and C, C and S, tangent, cotangent. Okay, so if I want to find secant, secant's the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then I'm trying to find hypotenuse over adjacent. So from theta, this is hypotenuse. That's opposite, I need adjacent, which means I need to do Pythagorean theorem. A squared plus b squared equals c squared, or c squared minus b squared. Take the square root and you got a. Okay. Just a little reminder. A squared plus b squared equals c squared. And if you're trying to find the hypotenuse, it's just c equals the square root. And then if you're trying to find one of these, then say you're trying to find a, then you subtract b squared, and then you take the square root, because that was a squared. Okay? So anyway, let's do 23 squared minus 21 squared. And I get 88. So the square root of 88. Okay, so hypotenuse over adjacent, hypotenuse is 23, adjacent is the square root of 88. Now the square root of 88 can be simplified. It's 8 times 11, which doesn't help me, but it means it's 4 times 2 times 11, which means 4 times 22. Square root of 4 is 2, so it's 2 square roots of 22. I'm going to go ahead and do that in a second, though. When it says 23 over the square root of 88, if I multiply by the square root of 88 on top and bottom, then these are just 88, right? So I've got 23 times the square root of 88, which is 2 square roots of 22, and then I've got divided by 88, and then I know that 2 and 88 are divisible by 2, so 1 and 44. So final answer, 23 square roots of 22 all over 44. Okay. Now, cotangent is the reciprocal of tangent, and if tangent is opposite over adjacent, then this is adjacent over opposite. So this is adjacent, I need opposite, I've got hypotenuse, right? Now, this is a 30, 16, or not 30, 60, 45, 45, 90, but I know because that's 6 and 6 squared to 2. Let's go ahead and do hypotenuse squared minus side squared, and then take the square root, and that equals the other side. In this case, O, or opposite. Okay. 6 squared is 36. Square root of 2 squared is 2. 36 times 2 is 72 minus 36. Well, 2 36s minus 1 36 is just 1 36. So it's the square root of 36, which is 6. Okay? So, opposite, or adjacent over opposite, or 6 over 6, which is 1. So the answer is 1. Okay. Use the given point on the terminal side of the angle theta to find the value of the trigonometric function indicated. So tangent of tangent of theta, given the point -10, -9. So if I plot that point, I go to the left -10 and down, or go to the left 10 and go down 9. And draw my triangle. This is a -10 and this is a -9. Okay? Theta is always with the central angle, coming from the x-axis. So it says tangent. Tangent is opposite over adjacent, so that's opposite, that's adjacent. So -9 over -10 is a positive 9/10. And there you go. Okay? So now let's do this one. It says sine of theta with 7 and -3. So sine is opposite over hypotenuse. So if I go over 7 and down 3, positive 7, negative 3. Hypotenuse is a squared plus b squared equals c squared take square root, which is the square root of 58, which is 29 times 2, which does not, is it 29? Yeah, it's 29 times 2, which doesn't solve the problem. Okay, so this is the square root of 58. Okay, so sine is opposite of hypotenuse, negative 3 over the square root of 58. Rationalize by multiplying by the square root of 58 on top and bottom. And I get negative 3 square roots of 58 over 58. And there you go. Okay, now this one says find the value of the trig function indicated. And it's saying find cosine. If cosecant is negative 5/4, well, cosecant is reciprocal of sine, and sine is opposite of hypotenuse, so this has to be hypotenuse over opposite. Now, hypotenuse is never negative, so the negative has to go with opposite. Well, if you think about your bow tie, opposite are the y's, and they're only negative when you go down, so it's not here and it's not there. Okay? Now, cotangent is positive. Cotangent is the opposite of tangent, and tangent is so if tangent is opposite over adjacent, then cotangent is adjacent over opposite. But I already know that opposite's negative, but then I know that this whole thing needs to be positive. The only way to get a positive, if you divide by negative, is if adjacent is also negative. And adjacent is the x-axis, and the only way that it's negative is on that quarter, not that one. So, I know for sure that I'm drawing in the third quadrant, and hypotenuse is 5 and opposite is negative 4. Okay, which means this needs to be 3 because it's a 3, 4, 5 triangle, right? Now, don't leave it as 3, it's actually a negative 3, okay? So then we're trying to find cosine. Cosine is adjacent over hypotenuse, so negative 3 over 5. And that is my answer. Okay? Alright, let's talk about 66. Find secant if tangent is negative 3/8 and cosecant is greater than 0. So cosecant's positive. Well, so tangent is opposite over adjacent. So basically, if opposite over adjacent is negative, that means one of them is negative and the other one's positive, which means they're in alternating signs. They're both positive here, so I know it can't be there. And they're both negative here, so I know it can't be there. Okay? Now, the fact that cosecant is positive, remember, cosine is the reciprocal of sine, S and C, C and S. So, hypotenuse over opposite, but the only way that cosecant is positive, because we know hypotenuse is positive, is if opposite is positive. Because if opposite was negative, then you'd have positive divided by negative, which is negative. So this has to be positive, which means opposite is the y, the vertical. So that has to be positive, can't be here. Okay? So I'm actually dealing with a triangle in this quadrant. I know the opposite is 3, I know adjacent is 8, and I know the negative needs to go with the adjacent, because this one's to the left and where's that one's at. Now, if I want to do Pythagorean theorem, a squared plus b squared, take the square root. So I've got the square root of 9 plus 64, which is 73. So I've got the square root of 73 is the hypotenuse. And secant is reciprocal of cosine. Well, cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So hypotenuse is square root of 73, and adjacent is negative 8. I don't like the negative on top, so let's just flip it to the middle. I got positive. And there you go. Okay? Alright, let's go 67. It says, convert each degree measure into radians and each radian measure into degrees. 100 degrees. Well, in order to convert from degrees, you need to multiply by. Degrees need to go on bottom, and radians need to go on top. Yeah? So the main thing we need to remember is that pi equals 180 degrees. I know the same thing, pi radians. So pi radians equals 180 degrees. So this is fraction is just 1. 100, the degrees cancel out, 1 0 from each, and then because 100 divided by 180 could be said it's just 10 over 18, and then they're both even, so I'm going to go 5 over 9. So the actual answer is 5 pi over 9 radians. Okay. Now 17 pi over 12. I'm going to cancel out, well, you got two options. Either just cancel the pi out and write 180 degrees in its place, or multiply by 180 degrees over pi. Pi's cancel out. I'm left with 180 divided by 12. Well, I'm going to divide them both by 30. I know this is 4, I know this is 60. Then they're both even again. I think I can actually divide 60 by 4, and it's 15. 15 times 17 is 15 times 15, which is 225, plus 2 more 15, so 255. Okay, so 255. Now it says find the correct value of each of the trigonometric functions after filling out the unit circle. Okay, so let's fill this out. So first of all, if I just plot the point, if I go over 1 on the coordinate plane, this point right here is 1 0. So 1 0 0 1, negative 1 0 0 negative 1. All these are divided by 2. And then also remember that in the quadrants, and you're thinking about that x and y coordinate plane, when I go this way, x is positive and y is positive. When I go this way, x is positive but y is negative. When I go this way, x is negative, and when I go up, y is positive. So these are negative here. And then in this quadrant, they're both negative. Okay, so let's fill out our numbers. That's 0, so this is 1, 2, 3, square root of 2 and square root of 3, and then 1, square root of 2 and square root of 3. Okay, so 0, 1, square root of 2, square root of 3, 1, square root of 2, square root of 3, 0, 1, square root of 2, square root of 3, 1, square root of 2, square root of 3, 0, 1, square root of 2, square root of 3, 0, 1, square root of 2, square root of 3. Okay, now I need to figure out the radians and the decimals, yeah? Oh, I totally just left half of that off the screen. Yay, okay. So, 0 degrees, 360 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees. I just went by 30s. So by the same token, I could go by, see if there's 30, or there's 6 30-degree arcs from between 0 and pi, which means this is 1/6. 2/6 is 1/3. 3/6 is 1/2. 4/6 is 2/3. 5/6. 6/6 is 1. 7/6. 8/6 is 4/3. 9/6 is 3/2. 10/6 is 5/3. And 11/6 is right there. Okay. And then the rest are, that's 0 and 2 pi. Okay. The rest are quarters. See, this is a 45-degree arc, another 45-degree arc, a 45-degree arc, and another one. There are 4 of them between 0 and pi. So this is 1/4. This is 2/4. This is 3/4. 4/4. 5/4. 6/4. 7/4. And then as far as degrees go, it's halfway in between 45 degrees 135 degrees, so it's 15 away from the 30-degree arcs. So 15 away, 225, 315. Yeah? Okay. Now it says use this to answer these other questions. You can wait a few more minutes. Okay. So the first thing it says find cotangent of 3 pi over 2. So there's a couple things you need to remember. In these coordinate points right here, the x is cosine and of theta, and the y is sine. Okay? You also need to remember that tangent of theta is, like we said, opposite over adjacent, but it's easier to deal with it as sine over cosine. Okay? Which means cotangent is cosine over sine. If cosine is x and sine is y, then we're talking about tangent is y over x, and cotangent is x over y. Okay? So, cotangent of 3 pi over 2. 3 pi over 2 is down here at the bottom. Okay. So cotangent. So cotangent is not sine over cosine, but cosine over sine. So cosine over sine. So 0 over negative 1, which is 0. Okay? Cosine of negative 4/3 pi. Well, this is 4/3 pi. A full half circle and then another 60 degrees. So we need to go backwards that much. A full half circle and then another 60 degrees. Which means cosine of negative 4/3, same thing as positive 2/3. Okay? Cosine is the x coordinate, so negative 1/2. Okay? Secant of negative pi over 2. Well, if that's positive pi over 2, then there's negative pi over 2. Secant is the reciprocal of cosine. Cosine is 0, and the reciprocal of 0 is 1 over 0, which is actually undefined. Okay? Let's talk about cosine of 11 pi over 6. Here is 11 pi over 6, and I got a lot of cosine questions. Oh well. Cosine is square root of 3 over 2. Okay, sine of 3 pi over 4. 3 pi over 4 is the y value. Sine, square root of 2 over 2. Okay. 7 pi over 6 right here. Secant is again the reciprocal of cosine. If cosine is a negative square root of 3 over 2, then negative 2 over the square root of 3 rationalize. So we've got negative 2 square root of 3 over 3. Sometimes you talk too loud while I'm making a video. So, okay, shifting up 2, so that's my new midline. Amplitude is positive 2, so go up 2 from there and put a dotted line, down 2 from there and put a dotted line. And it says, remember the formula for period is 2 pi divided by b. And remember that b is the number in front of x. And so in this case, it's actually a 1/3. This is the same thing as saying cosine of 1/3 theta. Okay? So, 2 pi divided by 1/3. Dividing by 1/3 is the same thing as multiplying by 3, the reciprocal. Because if you multiply on top and bottom by 3 over 1, those cancel out and you're left with 6 pi. So, yes. So, cosine normally looks like this. And if the period is 6 pi, then that's what it should look like at 6 pi. It should be right here at 3 pi, and then half away, so 1.5 pi. So at 6 pi, at 0 should, that's the max. At 6 pi, it should be back at the max. At 3 pi, it should be at the min. At 1.5 pi, it should be at the center. And at 4.5 pi, it should be back at the center. So it looks like every 3, 1.5 is each quarter of it. So I know I need to be back here or there. And at 9 pi, I need to be back at the base. So okay, so there's that one. Now let's grab this one. We shift up 1, and then we have an amplitude of 3, 1, 2, 3, and an amplitude of 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, Okay, so on this one, the period is just 2 pi divided by b. B is just 1 because there's nothing written in front of it, so the period is 2 pi. It's a negative sine wave though, so normally sine wave looks like this, but a negative sine wave starts at the center but goes down and does that. So that should be 2 pi, which means that should be pi, which means that should be half pi and 3/2 pi. So start at the center, 2 pi be back of the center, pi be back of the center, but half pi you need to be down below, and 3/2 pi you need to be back up. Okay. Every 2 tick marks, it looks like you're doing another quarter, so we could go here, and then back up here. Okay? Alright, so on this one, we need to go down 1, and then we need to go 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. And then the period equals 2 pi divided by b, which is 2. Those cancel out and you're left with pi. This is a negative sine wave again, so here's my negative sine wave, only this should be pi, not 2 pi, which means that should be half pi. So I should start here. At pi, I should complete my wave, right? Half pi should be right there. This should be minimum, this should be maximum. And then I'm going to do it again. Min, center, max, center. So down, back up, back down, back up, back down, okay. And then, I know that so I should be here and then back here. On there, okay. Okay. On this one, I only want you to graph on this window, and I want to go up 3. Okay. And then I want to go up 2.5, so from 3 that's 5.5. And then down 2.5, which means 0.5. And then my period is 2 pi divided by 1/4. Divided by 1/4, same thing as multiplying by 4. So 2 pi times 4 is 8 pi. So out to the side, I'm going to draw a sine wave. And then this is 8 pi. And I'm going to go ahead and draw another one on that side as well. So this is negative 8 pi, right? Well, you're only graphing from negative 2 pi to 2 pi. So if that's 8 pi, halfway is 4 pi. And then that's 2 pi. So you should only see this much wave on this side. So at 2 pi, it should be at the max. And then you should only see, if that's negative 4 pi, that's negative 2 pi, this much wave on that side. And there you go. Okay. So now, okay. Amplitude is the number, so if I have a sine of bx plus c plus d, you don't need to worry about that right now. You worry about that next. This is vertical shift. This is amplitude, and this has to do with period. It's not actually a period, but remember, 2 pi over b is period. Okay, so amplitude is 28. I said sine or cosine, so let's do sine of, I don't know, bx. So I gotta put an x, and I'll figure out b in a second, and then vertical shift is negative 14. Well, period is 2 pi over b, so 2 pi over b equals 5 pi. Okay, if I want to solve, then multiply by b. And then I'm going to divide by 5 pi. So those pi's cancel out, b is 2/5. And there you go. Is this some of y'all's last day with me?
Yeah, it is mine. No, I'll be back. My last minutes as a sophomore.
Is this some of y'all's last day at all?
Yeah, mine. I'm coming back for band, but that's at 4.
Well, goodbye.
I'm gonna miss not taking notes in here.
Yeah. They're just gonna be working, so if you want to come in and.
Can I come in and work?
Sure.
Awesome.
That is fine with me.
Wait, do I need to like
Well, it's just you, me, and
leave
Patricia.
and exit the school? Because like I'm not gonna go to first period.
We're the
I don't have
best
to
to the class.
Right.
But
Stay an extra day.
When?
Can I like park by the band room and then like leave after?
See you tomorrow.
Whenever you're done with all your testing? Yeah.
No, like tomorrow first period.
Oh, okay. Yeah. It has been a pleasure.
It has been a pleasure. I love you.
Okay, bye. I'll miss
I'll
you.
come see you. Cause I stay still next to you.
Hey, and if you get if you start thinking about me and just watch this video,
Okay.
and our
I'll just
goodbyes,
follow you.
you could.
What we're gonna do is
I will.
I'm gonna say just
Like randomly once in summer.
Stalking is bad. Don't ever do it.
I'm gonna dig into the police.
Yes.
Oh.
I'm gonna dig into the police files, my stepdads, and I'm gonna find you, and then I'm gonna come to your house.
And so this is my last will and testament. Bye, Connor. Bye, Presley. Bye, Charlie. Bye, Patricia. And goodbye to you. But I'll probably see you. I should see you for the test. And so, okay. Period 2 pi over b equals 3 pi over 4. When you've got two fractions equal to each other, it's kind of easy just to go ahead and cross multiply. 4 times 2 pi is 8 pi. B times 3 pi is 3 pi b. And then you want to solve for b, so divide by 3 pi. Those cancel out and pi's cancel out. B is 8/3, so I just put an 8/3 in there. Okay? Alright, last two. On this one, here's what I noticed. I'm always going to figure out where do I start, and the fact that I start and it looks like I go up to 4 and down to -4 means I don't go up or down any. So like if I was trying to figure out a sine or cosine of something x and then something. Well, I didn't go up or down any, so that's plus 0, or I don't have to write it at all. My amplitude, I'm going up 4 from the top, or 4 from the center, so 4. It looks like it starts at the center, the origin, and goes up like this, which makes it a sine wave. And then here's what I noticed. I noticed that my period, one full wave, is over by the time I get to pi. So if 2 pi divided by b, which is my formula for period, equals just pi, then if I multiply by b, 2 pi equals pi times b, divided by pi, b equals 2. And there's your formula. Okay? Now I'm looking at this one, and I notice that the highest is -1 and the lowest is -3, which makes me think this is the center, which makes me think that I needed to go, that I went down to. So so down 2. Okay. The amplitude, well, if between 2 and 1 and 2 and 3, that's just 1, so I don't even need to write it, but I'll go ahead and write that. The fact that I don't start at the center means it's not a sine wave. It starts below, so it's got to be a cosine wave. And then here's what I know. If I think about a cosine waves normally start like this and go like that, and that's one wave. Well, ours is starting from below, which means it's a negative cosine wave. And then last thing, I know that this part right here is like this part right there, which is only half of the wave, right? Well, that means from 0 to 6 pi is half, which means the period of the wave is 12 pi. So if the formula is 2 pi divided by b equals 12 pi, then I'm going to multiply again by pi, and by pi I mean b, and then 2 pi equals 12 pi b, divided by 12 pi, and pi's cancel out, b equals 2/12, which is 1/6, and there's your answer. Okay, sorry about that last bit, but there you go.